So, good morning, students. Before starting the quiz, let us have some lecture on the game theory. So, last time I have given you idea about the game problem, two-person zero-sum game. So, in continuous of that, the solution of the mixed strategy. Last time I have given you an idea about the pure strategy game problem. Now, if we have the mixed strategy, so how we can determine the compromise solution? So, solution of mixed strategy game. So, we have the two approach. We can determine through the graph or through the linear program. So, you have the idea of the linear program from your optimization course. I think all of you have completed this course. So, from that, you have the idea how to solve the linear program, LPP, simplex method, dual simplex method, revised simplex method, all the things. So, we have to use those method here also. So before starting the linear program method, we have the graphical method. So, graphical method is useful, right? First, it is suitable only when any one player must have only the two alternative, then only you can apply the graphical method, because in the graphical method you require the access. So if any one player has only two alternatives, other player can have as many as possible, right? But one player must have only the either the player A or player B must have the two alternatives only, then we can use the graphical method. And graphical method provide the base to extend for the linear program. Means whatever the idea we will collect in the graphical method, that we apply in the linear programming solution. So linear programming solution is applicable for the problem where the both player have the number of alternatives, means more than two alternatives, then we can apply the linear programming problem. So means from the graph we can visualize what is the saddle point in the mixed strategy game problem. So what I have told you, here we have the payoff matrix for the player A. So on this side we write the all the alternatives of the player A, and here we have the all the alternatives of the player B. So here you can see player A has only the two alternatives, A1 and A2, and player B has the alternative B1, B2, Bn, and corresponding here we have the corresponding payoff matrix. So here always we write the payoff matrix for the one player only. So in this case, we compute the optimal. What is the method for the pure strategy? We have used the best of the worst. The same method we will use here in graph also. So optimal strategy for the both player assign the non-zero probabilities to the same number of pure strategies. Pure strategy. Therefore, if one player has only the two strategy, then the other will also use the same number of strategy. In the optimal strategy, you have seen whatever the number of optimal number of strategy for the particular player, right? The same number will be for the other player also. If player A has two optimal strategy, then player B also has the two optimal strategies. Hence, this method is useful for finding out which of the two strategy can be used. So here you have seen in the graphical method, here we have the A1 and A2. So these two are only the optimal strategy for the player A. So anyone out of the B1, B2, Bn, any two will be the optimal strategy for the player B. And those two strategies we have to determine. That is the procedure for finding the solution for the right? Solution for the mixed strategy problem. Now in this case we compute the age expected payoff, because probability is involved directly here, so we have to compute the age expected payoff. For that, what we will do, let let x1 x2, let x1 x2 are the associated probabilities corresponding to the alternative 1 and alternative 2, and let here the y1 y1 y2 yn are associated probabilities corresponding to the alternatives, right, alternatives of the player b, such that such that you know the what is the total probability, it is equal to 1, so such that x1 plus x2 is equal to 1, and y1 plus y2 plus y3 plus yn is equal to 1. So xis and yj are the associated probabilities corresponding to alternatives of the player a and alternatives of the player b. So from here what we have, x2 is equal to what, 1 minus x1. So here the x2 is what, 1 minus x1. So if you have to compute the expected payoff, so expected payoff we have to compute. So what will be the expected payoff we can write? So here we have to compute the expected payoff. So expected payoff will become the a11 into x1 value into probability plus a21 into x2, right? So when we have the a11 x1 plus a21 x2, x2 is what, 1 minus x1, so it will become a11 x1 plus a21 1 minus x1. So this can be written as a11 minus a21 into x1 plus a21. So this is the expected payoff corresponding to pure strategy b1 for the player b. Similarly for the pure strategy b2, it will become a12 minus a22 into x1 plus a22. Similarly for here the expected pay for the here the expected payoff will come a1, it should be the n, I think. If so a1n minus a2n x1 plus a2n. So these are the expected payoff. So here we have computed the expected payoff for the j is equal to 1 to n. So in this case age expected payoff corresponding to b's jth pure strategy is computed as aij a1j minus a2j into x1 plus a2j, where j is equal to 1 to n. So let us have this problem. Solve the following games graphically. So from here we from this example I will show you how to solve the problem. So solve the following games graphically. The payoff is for the player a. So player a game is given to you. So here we have the a1 a2, and player b has the three strategy b1 b2 b3, and payoff is given to you 1 minus 3 7 2 4 minus 6, 1 minus 3 7 2 4 minus 6. So this is the payoff. So first of all we have to decide whether it is the pure strategy problem or not. So what is the pure strategy solution method? We compute the row min, and here we compute the column max. So column max is what, 2, here the column max is what, 4, here column max is 7. Row mean here we have the -3 and here we have the -6. From here, we compute the max min. So this is the max min, and from here we compute the min max. So here we have the min max. So here you can see that max min is not equal to min max. So when we have this result min max, so we can say it implies that it is the mixed strategy problem. Mixed strategy problem. Not, it is not a pure strategy problem, right? Not pure strategy, pure strategy problem. Not pure strategy problem. It is a mixed strategy problem. And when we have this situation, always, always the value of the game lie between the max min and min max. So it means for this question, the value of the game lie between the -3 to 2 only. So now we have to determine the value of the game. So here we have, here we have the game b1 b2, means these are the alternatives. So 1 2 -3 4 7 -6. So here we have to assume, let x1 x2 be associated associated probabilities corresponding to corresponding to corresponding to pure strategy a1 and a2 respectively, such that such that x1 plus x2 is equal to 1. Let y1 y2 yn be associated probabilities corresponding to pure strategy b1 b2 bn respectively, such that such that y1 plus y2 plus yn is equal to 1. So here we have the two strategy, x1 x2, and here we have the strategy y1 y2 y3. It's better you write, because it is, we have the 3 only, so it's better you write the y1 y2 y3. So y1 plus y2 plus y3 is equal to 1. So when the x1 plus x2 is equal to 1, this will implies x2 is what? 1 minus x1. So here we compute the age expected payoff when we have the B's pure strategy. So B's pure strategy and expected payoff. Expected payoff of player A. Player A. So when the B is playing the alternative B1 or B2 or B3, then what will be the expected payoff for the player A? So as I have told you, it will become 1x1 plus 2x2. 2x2, and x2 is what? 1 minus x1. So 1x1 plus 2, 1 minus x1. So this will become minus x1 minus x1 plus 2, minus x1 plus 2. Similarly, it next will give you minus 3x1 plus minus 3x1 plus 4x2. 4x2. So it will give you minus 3x1 plus 4, 1 minus x1. So it will give you minus 7x1 plus 4. Similarly, from here we have the 7 on minus 6. So 7x1 minus 6x2. So 7x1 plus minus 6, 1 minus x1. So it will give you 13x1, 13x1 minus 6. So from the expected payoff, so here we determine the right optimal value of the x1. So for that we use the right for that we use the best of the worst. So here we draw the graph between the x1 and value of the game. So here we have the axis of the x1. So x1 is what? Probability lie always between the 0 and 1. So let it is 0, let it is the 0.5, and let it is the 1. And value of the game can be the positive, can be the negative. So you have to draw the, let's see, both axes. So 2, 4, 6, 8, 10, 12, right? Let it is the 2, 4, 6, 8, 10, and 12. Here we have the minus 2, minus 4, minus 6, minus 8, and minus 10, minus 2, minus 4, minus 6, minus 8, and minus 10. So now you draw the first expected payoff. So first expected payoff is minus x1 plus x2 plus 2. So when x1 is equal to 0, when x1 is equal to 0, it is the plus 2. When x1 is equal to 1, x1 is equal to 1, it will become minus 1 plus 1 plus 2, that is the plus 1. So here we have the plus 1. So this is the line of first expected payoff corresponding to the b1, corresponding to b1. Then we have the minus 7x1 plus 4. So when x1 is equal to 0, it will be the 4, it will be the 4. When x1 is equal to 1, it will become the minus 3. So it will become minus 3. So here we have the line of expected payoff corresponding to b2, corresponding to b2. Then after we draw the third line, 13x1 plus minus 6. So when x1 is equal to when x1 is equal to 0, it will give you minus 6. When x1 is equal to 1, so it will give you 7. So here we have the 7. So this is the line so this is the line corresponding to b3. So from here, right, so you have drawn the expected payoff. So from here, now what is the our best of the worst? So first we take the what is the worst one, right? What is the worst one? And from that we compute the what is the best one. So you know that corresponding to row, Corresponding to row, what we compute? We compute the row min, right? So first we compute the what is the lower envelope. So here we have the lower envelope. Here we have the lower envelope, means these are the worst one, corresponding to B3 and B2. Corresponding to B3 and B2, we have the lower envelope, and from the lower envelope, we have this is the best point. So from here, so lower envelope, because in the you have seen here we have to compute the row min first row min, then we have to compute the max. So from here we have computed the expected payoff, so we are computing the max of min. So first we compute the lower envelope, and from the lower envelope we compute the maximum point. So lower envelope will be the, right? So this is the lower envelope. So here we have the equation, means if you compute the intersection point, so B3 is the 13 minus 13x1 minus 6, and B2 is minus 7x1 minus 7x1 plus 4. So when it will give you the point x1. So here we have the 20x1 is equal to 10. So x1 is equal to 1 by 2. Let's check, because I think in my graph, yes, x1 is equal to half. X1 is equal to half. So when we have the x1 is equal to half, so x2 automatically will come as a half, since it is the 1 minus x1, 1 minus x1. And when we put in any equation, this is the value of the game also. So the value of the game will become 13x1 minus 6, or minus 7x1 plus 4. So it will give you, when we put the x1 is equal to half, so it will come 6.5 minus 6, so it is also the half. So here, from here you can see that at the means this is what, this is the 0.5, and here the value of the game, this is also 0.5. So when we have the value of the game, right, so you have computed the associated probabilities also corresponding to the player A. Now we have to compute the associated probabilities corresponding to B. So for that we compute the expected payoff for the player B. Expected payoff for the player B corresponding to pure strategy of the player A. So pure strategy of player A. Player A has only the two strategy, A1 and A2, and expected payoff of the player B. Expected payoff player B will be. So in this case, we have seen we are getting the lower envelope corresponding to B3 and B2 only. When we have such thing, so automatically Y1 will be the 0. Only you have to take the Y2 and Y3. Because in the optimal strategy, if the player A has the two alternatives, then player B also has the two alternative only. So B1 will not be the optimal strategy. So we will take the Y1 as a 0. As we take the Y1 as a 0, and we know that Y1 plus Y2 is equal to Y1 plus Y2 is equal to um, we have Y1 plus Y2 plus Y3 is equal to 1. So this implies that Y2 plus Y3 is equal to 1, or you can say Y3 is equal to 1 minus Y2. 1 minus y2. So A pure strategy when we have, so B's expected payoff will become, because here we have the minus 3 7 4 4 minus 6. So it will become the 3y2 minus 7y3, eh, minus 3 minus 3 minus 3 plus 7, minus 3 plus 7, and 4y2 minus 6 y3. This will be the expected payoff. And y3 is what? Y3 is 1 minus y2. So this will become minus 3 y2 plus 7 1 minus y2, and this will become 4 y2 minus 6 1 minus y2, 1 minus y2. So it will give you minus 3 by 2 minus 7 by 2 means minus 10 y2 plus 7, and this will give you 4 by 2 plus 6 by 2 means minus 10 plus 10 by 2, and here we have the minus 6. So because we have the two line, need not to make the graph, just you have to compute the intersection point. So minus 10 y2 plus 7 is equal to 10 y2 minus 6. So this will come 20 y2, 20 y2 and 13. So y2 will be the 13 upon 20. So when the y2 is equal to 13 upon 20, so y3 will be, y3 will be the 1 minus y2, that is the 7 upon 20, and y1 we know that it is already 0. It means what are the optimal strategy? Optimal strategy is player B must use the alternative b1 b2 b3 with probability 0, 13 by 20 and 7 by 20, right? And player A must use the alternative a1 a2 with probability half and half, and the value of the game will come as a half, right? Value of the game will come as a half. So that is the solution. Clear? Yes.